Hello and welcome to Identirati Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 168. The title is SAFE MCP and GovOps for AI. Our guests today are Frederick Kautz and Rohit Khare. Welcome, guys.
Hello, I'm Frederick. Thank you for having me. So, a couple things about me. So, first, I have an extensive cloud native background. I had committed access to Docker before it was publicly released, did a whole bunch of stuff there, not working at Docker, but through the community. Created multiple projects in cloud native storage and networking, co-chaired KubeCon. I have a strong AI background as well, did federated learning and differential privacy in HIPAA environments, created a HIPAA compliant AI platform for a Fortune 500 company. Also worked heavily in security, where some of the things I did there was I was on the steering committee for SPIFFE, which is cryptographic identity for workloads. Ran a major infrastructure based on it, wrote a book on it. I've written standards like the CTA's 2114, mitigating cybersecurity threats in ML-based systems. And I also started a project that we're going to discuss called SAFE MCP, and collaborating with the OpenSSF on this. So thank you very much for having me.
Rohit, maybe you could say a word. So you helped make this, catalyze this episode. Maybe you could just say a couple of words about how it came about.
Indeed. Thanks, Mike. In fact, good evening here, actually. I should offer dressed a little more formally. I'm actually live from Dublin, actually, in a 800-year-old castle. They're often
Wow.
Clontarf Castle here in Dublin. I'm here in memory and celebrating a good friend, so we'll dress more than usual. But dear friends include the people who have helped build a lot of interesting standards, and I had been following Frederick and some of his colleagues on the book he casually referred to, the Bottom Turtle book, kind of the community-written book about the ways to use this basic cryptographic infrastructure for microservices, SPIFFE Spire, and we've known folks at a couple of startups that have spun out of that. But I was even more excited that we've been in touch over the last year and a half as he's been looking more and more into the security of agents and distributed services and governance of them. And so given these trifecta, a couple of areas that I'm passionate about, that federated learning, governance, security, cryptography, I said you can come join the Identirati community and tell us a bit more about these areas and where we're going next. So, Frederick has been working with a couple of startups I also find pretty interesting in this space. But today's is about SAFE MCP, and I think for that we have to kind of step back and understand what are some of the antecedents for this idea of giving the community a framework and a way to talk about security problems. What led to this?
Yeah, so one thing I should have mentioned in the intro as well. So I have a lot of experience in writing guidance. And so part of it is I spent some of my time programming machines, and then I spent some times programming people through guidance. And we actually ended up reconnecting through, I had just finished, one of my guidance was on software supply chain security. So I wrote the guidance for the US government on that topic for DevSecOps environments. DoD ended up picking it up afterwards, but I had just gone. There was an event that we had at Plug and Play in Santa Clara that I had literally that day just had finished my first draft and had it submitted in. And I brought a copy of the draft that was that was published, like literally had just been published by NIST in draft form, and came over to visit some friends who were running the event, and we ended up reconnecting in that spot, and then that ended up chain of events where where we've been bouncing ideas forward and back to on a variety of different areas. AI security is one of them. But to really tie into like why this is that because one of the things I realized is that security by itself, even though people want it, companies don't really want security. They don't really care about it in most scenarios, except when it starts to hit the bottom line, starts to hit their compliance, and then they care about it very deeply. And there was an issue that we saw where companies were building AI products, specifically around LLMs to be very specific, because there are other AI products that have successfully made it to market without significant issues. But specifically the LLM ones making autonomous decisions or semi-autonomous, and people were unable to reason about them. They cannot quantify the risk. Because they cannot quantify the risk, they cannot meet their compliance, which meant that they couldn't get into production. So SAFE MCP was designed about quantifying that risk. So we started with the MITRE ATT&CK framework, and which is very broad. It's like, how can software be attacked, and what can you do about it? What are high-level mitigations? And we asked the question, well, what if we were to implement this guidance at a lower level? And let's just scope it down in the very beginning to MCP. And we asked that question for the MCP and its ecosystem, including the LLM, the things that it calls. What are the things that can go wrong that people are unable to reason about today, and how can we give them the tools to reason about them, and then tie them to their compliance? Like, you have this attack technique, you have this mitigation ties to this compliance framework, and that starts to give CISOs and teams who are delivering to the CISOs the ability just to reason through their through their products. So in a nutshell, that was the idea.
Yeah, if I could read back, so I watched your open source SecurityCon presentation. Was that at Atlanta this year before KubeCon?
Yeah, so this was actually part of it's a co-located event. So what we do at KubeCon is we always have a day, we call it day zero. So day zero events are on a variety of different topics, all of them related towards KubeCon or to Kubernetes or KubeCon or Cloud Native in some way. The full name of KubeCon is actually not just KubeCon; it's Cloud Native Con and KubeCon. So it's about Cloud Native and Kubernetes. It's sort of like a joint thing. And the 0 day provides a path for self-organized topics where people
Frederick, are you sure it's day 0 or 0 day? Because
I always forget. It could be 0 day.
I have to say, some of the best events were at SecurityCon, and maybe that's because that's sort of my area of interest. But I thought that the content was really excellent, and I like conferences where I walk into things where not knowing anything about it, and sort of like serendipity brought me to understand this for no other reason than I had nothing better to do at that 45-minute interval, and I walked into something interesting.
Yeah, we actually spun off SecurityCon for a period of time, and then we brought it back in. And this because KubeCon brings all of the clients, and trying to run a separate security conference outside of it, it takes time for the clients to bring up. And we thought, well, why are we going to struggle through this path? Like, let's just continue to drive it through KubeCon and get the security practitioners or the subject matter experts and the clients together in the same spot. So it's a really nice combination of the two, and the people who organize that specific conference always do an amazing job. I've never walked into it and been disappointed for showing up.
Contrast I was drawing is that these are interesting maturity differences, right?
Mm-hmm.
You've got Kubernetes, which has been past celebrating its 10th anniversary, MCP, which is just about a 1-year-old, and the brand new Linux Foundation-backed AI Agent Foundation,
Mm-hmm.
Which is, I guess, at year 0. It's something that's fresh for each time. Let's step back and say, well, what are some of the differences, how things evolved? One mega trend has been this microservices revolution of people's understanding of software security risks. Started with like RPCs and remote calls. Now we've thought about containerization and Docker, and then we thought about microservices and Kubernetes and pods, and now we have MCP. What's substantively changed? And you're kind of help set the stage for us about what makes these MCP risks versus traditional software risks, and we can take it from there.
Well, I think there's a lot of people like to take with the thing that they're doing and they say this thing is special. It's very different from what we did in the past. And the reality of it is that yes, there may be some meaningful difference that is there. LLMs are certainly a meaningful difference. But I think that what ends up happening is we have to look at the assumptions. Like back before Cloud Native, the assumption was your IT system would set up your database, they would set up your infrastructure. Then you as an application developer would then conform to whatever they set up. Now that ended up swapping. So the application developer is saying, I want to use this database. I want to go use CouchDB. I want to go use whatever they choose. And then the IT systems are now being automated and with their infrastructure as a service and similar through cloud. And a lot of that has, not to say that it's disappeared, but the interfaces have changed. So we're now at a spot where when we started talking about cloud native, if you look at like identity, I'll use identity since that's a spot that I know very very well, and also I know we have expertise here, for putting it mildly. And part of the path here is that when we set up the cloud native environments, we knew ahead of time what we were connecting to, what the interactions were likely going to be. We had like code that we can go and review and say this is what the behavior is going to be, and if we didn't like the behavior, we could always go and try to fix it. Of course, there's limitations on this, but it was something we could reason through. Now we're in a spot where we have people who want to be able to go to an AI or to an AI-based system and give it a random task, a task it's never seen before. And it has to work out. What can I connect to? What data can I send to it? What are the side effects that are there? And these are not pre-programmed things. So those assumptions have changed, but I think that the base infrastructure that we built is going to be strained, and we have to ask the question, how can we make what we've done so far become better adaptable or adapt better to the new assumptions that are coming along. So I think a lot of attacks occur when we apply those old assumptions to newer environments, and we don't do the last mile to get there. There are sometimes fundamental changes that require completely new paradigms, but I think at the end of the day, like non-human identities are probably still going to be based on JWT, OpenID. They're still going to be based on X509 certificates. The question then becomes, how do we issue those certificates? How do we apply policy? How do we reason about it at a speed that's faster and more adaptable than the static configurations that we had in the past?
I wonder what is really new about agentic AI interactions. Okay, there's an LLM making decisions, but what I wonder is that actually these challenges that we've had with interdomain trust and software identity, and one piece of software calling another piece of software, and whether they can be trusted, and whether there's a human who's authorized this. These are all challenges we've been dealing with for 20 years. And so I wonder, has agentic AI really changed anything? Or has the thing that it's changed is that agentic AI now has board level visibility and is seen as a board level business priority to get under control, and suddenly it's a blocker. Security is a blocker for what they want to accomplish on the business front.
I think I think the majority of it is still very, very similar, at least from an infrastructure and security space. So I don't want to downplay the capabilities that LLMs bring to the table when I'm saying these particular comments, because they're absolutely phenomenal. Some of the stuff that they can now do. When it comes to people, like at the end of the day, there was a talk I did in KubeCon a couple of years ago. I think it was in Chicago, where I spoke about trust specifically. And what I said about trust was that you cannot build a system that is inherently trusted. You can build a system that is trustworthy, that's designed to be for people to reason about. But at the end of the day, somebody has to make a decision. I'm going to trust this thing to do the thing for me, or this company is going to trust the thing. But it always comes down to people. Somebody there was making the decision to trust it. And that tied me back to a thing that was in an IBM manual back in 1979, where there was a phrase that said, a computer can never be held accountable, therefore a computer must never make a management decision. And if we tie that, I know it's oversimplifying things, but at the end of the day, people say, oh, an agent is running by itself. Well, yeah, an agent is making decisions, but it's making those decisions because us as humans have made a decision to allow it to make those decisions. So we've given it, somebody has trusted it somewhere. Whether that trust is misplaced or not is a different question. But that accountability, the machine is still acting as an agent of a person or of a corporation. And we must not forget that the laws don't say, okay, HIPAA applies except when it's an AI agent. They apply regardless as to whether it's a human, a classical program, a machine. maybe in the future a quantum system making a decision, but all of those regulations, they still continue to apply, though that accountability is still there somewhere. And we need to find new ways to reason about those particular paths and be able to answer the question, is what we're doing responsible?
That's what I wanted to summarize back to see if I understood the saliency of those 2 points you're asking about, Mike and Frederick, which is that the there's been the infrastructure core technology, the terms NHI or token-based access control. It's not a revolution that affects us rethinking the mathematical cryptographic foundations. But the revolution of affairs here is that trusting a person in an interdomain relationship has a human-like failure model. And we kind of know how humans fail through suborning, through misunderstanding, through malice, through accident, and at what speed humans fail, and what level of granularity and accounting humans want to give up at. Now we have this LLM shift, and the salient radical shift is they're tireless, but they're also continuous, and they're super fast, and they're going to fail in ways that make no human sense at all. That the need for least privilege is kind of counterbalanced by a mental model of the morality of the attack surface. And this is not a place to have a discussion about intentions and morality or so on. So if we look at the LLM as the salient difference between like an MITRE attack framework version of history and what SAFE MCP is trying to do, the autonomy is not the key. The technology changes are not the key, but the key is that the risk model has changed to the kinds of mistakes an autonomous agent system can make are very different than the kinds of mistakes or malice a human might make. And in that light, I was curious about touring a few examples that actually fits of SAFE MCP's gardens.
Yeah, I had an interesting question because I like to look at, in part of my standards and guidance writing, I like to look at what are the failure modes that the people themselves run into. Because at the end of the day, somebody has to reason about this. And that's why I ended up writing out the SAFE MCP, was I wanted to give people a catalog of different ways this thing can be attacked, different ways this thing can go wrong. Because now that you're aware of it, then you can go do something about it. And but one of the interesting ones that I found was I've had more than one person ask, if you have an AI system, how can you have a non-AI system? Is it even possible for a non-AI security apparatus to control and protect an AI-based system? And for me,
so ironic, given you said Bottom Turtle as the title of your book, and Bottom Turtle as the main name we're going to try there, because if the only thing that control an AI system is a deterministic non-AI system, is my guess.
Yeah,
and turtles all the way down, or if it's a LLM as judge, we've seen the papers like Camel and so on saying that there's some fundamental gaps in trusting one a non-deterministic system to control another non-deterministic system safety.
And
or you might have like a stun gun or live goldfish show up in your vending machine, like from the article we referenced. Yeah.
I think there's two things that I found interesting. So first, people tend to think of security as binary. It's secure or it's not secure. The reality of it is that security is actually more of a multi-dimensional gradient. Like
it's a choice on a frontier of possibilities. Pick a menu of risk and reward.
Exactly. So I can build an LLM prompt that's designed to try to find, is this thing going to try to do a prompt injection against another LLM? And I can then have it work in that particular space. What I've done is I've reduced the risk, but I've not solved the fundamental problem unless that LLM gets sufficiently smart enough, which we're not there yet. And so it's more a question about like what is the risk level that can I drop the risk level, and can I down to a point where I'm willing to accept the risk that remains. And if you're not able to reason about your risk, then you're not going to get there, or you're going to accept it, but you're going to have no idea what you're accepting. That and also tying to that, I'm also the belief that security is a function of economics, as in, as a defender, you have something of value that you want to protect, and you're willing to spend some amount of resources to protect it. And as an attacker, the attacker has something they want to that they want to compromise, because there's something of value that they want as well. And there's an amount that they are willing to spend to compromise that particular system. So the security people often only look at their own capabilities and say this is the risk, but you have to consider both sides. If you have a state actor who really wants that data, then your risk profile is going to be way higher than, let's say, somebody puts together like a Angry Birds clone for their family, and you're protecting a scoreboard that doesn't even have real names in it. It's like you don't have an attacker there who is going to be at the level of advanced persistent threat, who's going to want to focus a significant amount of attention on it. If they do a drive-by and manage to find an exploit because you didn't patch it, okay, they'll do something with it. But it's like you have to look at both sides. Like, from a defender, what are you willing to do, and how much are you willing to pay? And an attacker, and once you have those together, you can start looking at the economics of the thing that you're trying to defend, and try to reason about that risk.
So I wanted to actually, it's interesting because we've talked about accountability. You know, your IBM reference about somebody's ultimately accountable. We've talked about risk and how security isn't about eliminating risk, but hopefully prioritizing which risks that you need to address so that you've addressed enough of the big ones. If you miss a couple of the little ones, they're not going to put you out of business. The last piece that we haven't really addressed is transparency, because I would argue that to build a trusted system, or to really do a good job governing a system, we need to prioritize those risks. We need to hold either business units, people, or software accountable when things go wrong. But the last ingredient here, I think, is transparency. How do we build a transparent system in order to encourage this trust? And does SAFE MCP help us do that?
That is a good question. There is some discussion within it that talks about transparency when you're talking about mitigations. One of the things that security practitioners tend to know very well is that some of the controls are after the fact, after the thing has happened. If you have a security camera, it's capturing what happened. It's not stopping the thing from happening directly. But those detective controls can be used afterwards to try to work out why did this happen? Who was it? What can we do differently to stop it from happening again? Holding someone accountable for doing the thing they shouldn't have done. So it's the same within cybersecurity, and we absolutely have to have if we cannot observe to some degree or trust somebody to observe sufficiently, then that's a system that we probably shouldn't trust in order to make its work, or in order to make decisions. This is problematic to a degree because when you're looking at LLMs, this is like one of the things that it changes. There was a question that I struggled with when I was originally working with AI, and I still struggle with it, which is if you have an AI and it makes a decision, it doesn't have to be an LLM. It could be like a convolutional neural network looking at an image. Like, is this thing present or not present?
And if I could just qualify, it's the agent that's making the decision based on input from an LLM or input perhaps from an expert system. But it's not the LLM that's making the decision. The LLM's giving you some good options about decisions that could be made. But ultimately, isn't it the agent that's making the decision?
Well, that depends on what you define as agent here as well. So a lot of developers are classifying agent as like a piece of software that has that has an LLM or some other similar thing attached to it that's working autonomously, and the LLM will say, I want to use this. And then the agent has some roles that say whether that thing can happen or not. And then it goes off and
like our vending machine, for example, at the Wall Street Journal. Like the LLM came up with some crazy ideas, but ultimately the vending machine decided to order live, fish.
So there's a difference when we start talking about these kind of things. One of the first things we want to do is come up with like terminology. Like when we say this, what do we mean? One of my favorite examples of that is the term policy. when I talk to developers and I say the word policy, they're thinking, oh, that's the act control list that's there. That's the rule that I just implemented. When you talk to someone who's in the executive level, or they're working with the CISO or compliance, or like, oh, policy, that's the stuff you put in that says all data at rest must be encrypted. And it's I one day want to do a talk where I will use the term policy and create a talk where, depending on what type of audience member you are, you'll interpret it differently, and then close the talk with saying, here's how you all interpreted it, and this is why we need to talk about terminology. So I'll do that one day.
Talk where it's like, wait, I thought you were telling insurance policies or security policies.
Exactly.
But we'll play. Yeah, that's a very clever idea. I'd love to do it, but coming back to grounding it.
Yeah, coming back to the main thing here.
There's a regulatory perspective.
Yeah, and tying it back to the topic of like transparency and decisions. And like if you have a thing that makes it makes a recommendation, it has some output. It says, statistically, I think this is what you should do next, and the decision is wrong, and it costs somebody. Worst case scenario, cost somebody their life. Then, but it's not theoretical. These kind of things are happening. You have
that's the murder bot. It's an armed bot, and it killed somebody. Yes.
But
okay, go on.
But it could be an accident. It could be a self-driving car that made a bad decision. It could be cancer detection. Cancer detection made the wrong detection. So when you start looking at that, if that's where like the explainability becomes incredibly important, because you'll have a difficult time telling whether something should be used or not, whether you should trust the output of something or not. And there's different kinds of transparency. You have like for lack of a better phrase, you have like white box and black box style, borrowing terms from testing. Like white box, you'd be able to say, this is why I made this decision, and at a fundamental, at a mathematical level, versus like a black box saying, well, this thing is too complex for us to understand, but we've ran so many test scenarios against it that we're confident it's going to work the way that we think it's going to work. I think most LLMs and most complex enough AIs will fall into that latter black box style approach, where we just throw so much testing and so much data at it for those critical environments that we're willing to accept the risk of running it. But there still needs to have the transparency, because not if, but when it makes a wrong decision, we don't want that wrong decision to happen again. And that's indicative that we have something in our data sets, or maybe there's a limit as to how much the AI we're using is able to perform a task, and understanding what those limitations are becomes crucial towards increasing the total outcomes, maximizing the best outcomes.
So as we're coming on time here, and some more sense of like, now how can people contribute to it? What's the actual form of a SAFE MCP recommendation, or the kinds of clearinghouse we're looking at here, or the kinds of just even database and examples of past attacks? So, without getting, just curious again about what is some of the concrete forms it takes, and how do we use these recommendations, these behavioral guidelines, as we began at the top?
So
we will contribute.
Let me give a little bit of information how it's structurally set up. So SAFE MCP itself, there's a repository. It's safemcp.org, safe-mcp / and then the repo is the same, safe-mcp. So one way of helping is just to use it. Like go and see it, go and learn about it, because a guidance, a standard without users is it's actually, I'm not going to say it's zero value, it's negative value at that point, because the people writing it could have gone and done something else. So using it is helpful. If it's useful to you, share it with others. That's the first one. The second one is if somebody wants to get more involved, we have a special interest group within OpenSSF that is actually called SIG SAFE MCP. You can go and join it. And just as a heads up, we may actually rename it, because the scope has gone broader than MCP. So eventually there'll be a renaming, but we'll make sure that it's very clear of when the rename happens, if it happens. Just as a heads up. But the other one is if you want to contribute the licenses, if it's code, if there's any code snippets, it's Apache. If it's prose, it's Creative Commons. So, but feel free to contribute. You can contribute actual text, or you can review it. If you're reading it and you find something you don't like, or maybe it's not understandable to you, maybe there's an inaccuracy. Go and contribute, and we accept patches. And one of the things that we do for meaningful significant contributions is we're also giving attribution to the individuals if they want it. So so somebody can say, like, I helped write the SAFE MCP section on, like, prompt injection or rug pulls. So it's a way of the project simultaneously giving back to those individuals, because then there's a lot of standards out there. They won't ever say who the authors are, and the end result is that when they go and try to get a promotion, or they're trying to get they're trying to demonstrate knowledge in a space, it's much easier if the thing that you wrote that everyone is referencing has you as an author on it. So it's also an opportunity in both ways, where like, we're looking for high quality information. We're looking for eventually we're going to do reviews on all of it, because there are like 80 to 90 different techniques that we've written. All of them are like a full-blown research paper. So we're going to eventually put review teams that go over each of these very carefully. So if someone wants to participate with reviewing a specific topic, that's also going to be high value, to make sure that the information we're giving is high quality. Sorry, I blasted a lot of information out, but in short, come join us.
I wanted to ask sort of a qualifying question about why do this as a special interest group at OpenSSF. There's other, like, the first thing that I thought about was OWASP has some similar projects. There's one called Application Security Verification Standard. There's also OSCAL. We mentioned FedRAMP in the episode description. Where do you think SAFE MCP, or whatever it will be renamed that's maybe less pigeonholed to MCP, where do you think that organization fits, between OSCAL and OWASP especially?
That's a great question. And I also am aware that most people are probably not aware of OSCAL. So OSCAL came out of NIST. I actually gave a talk at a previous OSCAL event, so it's I know it quite well. And in short, what OSCAL is you have a schema that says, like, this is these are controls. It's like a catalog of controls, and then you have a way to demonstrate through a second schema that's compatible to say, like, this is how I implemented it. Or you can fine tune the controls to say, like, this is a control that fine tunes this one or replaces this other one. It provides a programmatic way to do this. And in fact, the new FedRAMP program that is being set up is being designed to ingest OSCAL as a form of evidence, as opposed to sending them a small book in form of a PDF. And that helps with continuous compliance as well, because you might have a firewall that's up. You can go see, is that firewall still running? And then that goes directly into your OSCAL, and you can automate that path. So that's a whole thing. In terms of
for listeners, that's FedRAMP 20X, like it was supposed to be the future of
yes.
FedRAMP 2020 or so on. It'll be, and regardless of the state of that program within the government and the bureaucracy at the moment, the idea is that OSCAL, versus certifications and regulations that were made to move paper and be read by auditors, OSCAL is if programmers wrote certification standards, and if programmers thought of it this way, they would think mostly, how can I script this? How can I automate this? It's another complementary piece of this puzzle. But it is telling that we've covered a lot of ground today, and a lot of different technologies at a lot of different organizations. Just as a point there about, look, what do we need for a really high assurance environment, or we called, I remember what mostly prompted this conversation and scheduling on the identity calendar is like ATO, authorization to operate, who come it all together. Let's pull all these strands together. The question is, a human, is responsible for running this autonomous system, and how do they develop security, the ability to sleep well at night, using these pieces and putting those together? I think back to asking you again the same question, because it falls in that space of not quite new technical standards, but very much new behavioral manuals for people and operating recommendations and best practices and putting the pieces together.
So one of the things I would love to eventually see is, and perhaps this is something that we can do, is to have like an OSCAL based SAFE MCP framework. But part of that, it would be for it to have a way to reference. And this has been I haven't looked at OSCAL to see if they fixed this problem, but there was a linkage problem they used to have. And I brought it up with them, and I believe it's been fixed. But the idea is like you have one control that might satisfy NIST SP 853, an ISO 27000 series control might satisfy something within SAFE MCP. And SAFE MCP has been written in such a way that if you say you brought in a specific mitigating control, then that too can link back to NIST SP 853 or others. So it's designed like as a meta framework to be something that you at least have some evidence at that point. That's not to say that it is compliant. That's something that you have to work through, and you have to work with not only yourself but your auditors to demonstrate. But to be able to say, like, if we have this, we believe that we probably have this this control covered, and that it performs that linkage and makes it a bit more clear. So I would love to have OSCAL based controls on this eventually, where such things could be attested through more autonomous means, or not autonomous. At least it makes the whole experience much easier for people who have to go through this, even if the control is still manual. The fact that you have something that's automated that helps you work out what your gaps are is also still a value. So
that's another term of art, the governance as code, right? Because again, reflect back to you what I'm hearing concretely. It's you might have a generic wording that says, to get your SOC 2, that do you have logging turned on, and is the logging safe and secure and can't be subverted? That actually comes into lots of specific rules. And if you actually gave ourselves a new challenge, like a 2026 era version of the problem, it's like, how would you teach an AI agent to be an auditor? Well, you'd have to teach it a bunch of rules and programs, and you might end up creating something like this linkage in this knowledge base. So,
and it moves as well. Like we talk about, like, is your network encryption sufficiently secure?
Mm-hmm.
I mean, we have things like FIPS to help answer that question, but you can see things that don't have FIPS, like what are you doing in terms of storing data? Is your data retention appropriate? You could have something that's compliant today, and a year from now, the regulations have shifted from any number of jurisdictions that you have to adhere to. And so having that ability to automate some of those, so that you can determine as time progresses.
I would say to automate and collaborate. Because a lot of belief has traditionally been in the governance, risk, and compliance space, and in identity governance administration, is that every organization is unique, and we have a unique snowflake, and we have unique needs for our industry. But right now, in part because there hasn't been tooling to share policies and recommendations, there also has been a belief that we don't necessarily have working groups that say, "Hey, we're just here to get this done, to turn SOC 2 into something meaningful for SaaS startups, for financial startups, for whatever vertical you'd like to think about."
But look at how much
a way to collaborate is a medium.
But look how much like SOC 2 moved the needle for people, where it became like, we'll have our auditors talk to your auditors effectively.
But still for the medium of English.
Yeah, and then you look at companies like Vanta and Drata, who then built systems that help, like, not to say that they automate all the things, but they automated much of the reporting to say, like, that you can go and fill out. So that has helped accelerate. That's also caused some issues as well, because they'll, depending on the interpretation, is it sufficient? Like, have you done enough to secure your system? Is not just I'm SOC 2 compliant.
Not a checklist.
So you want to avoid. What I like to tell companies,
in fact, I'd argue that I actually just wanted to make a couple of distinctions here. So there's best practices and there's compliance.
Yes.
And OSCAL, it seems to me, helps you map best practices to various compliance frameworks. So you might have a best practice that actually that is needed for SOC 2 and ISO and NIST, right? Standards. And it seems to me that SAFE MCP is sort of helping to provide a place to flush out some of these best practices so that they can be reviewed by compliance organizations and then codified. And then maybe at that point you will have OSCAL controls that map to these things. So seems like we're expanding the list of like best practices out there. But fundamentally, I think you're making a good point, which is that compliance is never enough. It's
Yeah.
the baseline. It's the minimum amount of stuff that you need to do to be able to show that you're a responsible organization. I got SOC 2 checked, but it doesn't mean a whole lot anymore. I've pointed out in a couple of posts how abysmal the security is of some of the companies who actually are SOC 2 certified. And so SAFE MCP is going to be a superset of this compliance framework. I imagine a pretty significant superset of that. Am I on the right track?
Yeah, I think you're on the right track, and I want to be really careful here, because what I advocate for people to do is first you do the right things, and when you do the right thing, you'll naturally check off much of the compliance, not all of it, but a significant portion of it. There is a last mile that needs to occur. Like if you're doing zero trust, maybe you don't need the firewall. I would argue you probably still need it, but for best practice. But because if your main control fails, your firewall is now your secondary control that helps keep people out. But suppose that you don't need the firewall there. The fact that you decide to put, and a control calls for it, you might just put one there because the control calls for it. You're not going to pass your audit without it. But when it comes to security, like my preference for engineering teams and groups is to spend time with the fundamentals and try to work on how to actually, like, that's why I spend so much time on the techniques first rather than the mitigations, is because I want people to know these are different ways that we catalog that you need to defend against, and it's not there to replace your thoughts. It's not there to replace your reasoning. You need to reason based on your risk profile, in what you're doing, and make decisions. And those decisions, ideally, some of them will help you with some of your compliance, and we would like to be able to check those ones off through an automated means. But compliance should never replace the concept of, like, am I secure? Am I doing enough? Like that's still a question that you need to ask, and and that's why I like some of the things, like, for all the problems of HIPAA, there's still an outcome based thing there. If someone breaches a system and they run off with a bunch of PHI, public health information, that is outcome based. It isn't, oh, you applied the 20 controls and so therefore you're not liable. It's like, well, it happened, you're still liable, even though you did all the best practice stuff. Now, how much they decide to go after you is based upon that best practice. Like, are they going to throw the book at you, or are they going to work with you to get you into a better place? And you still have to pay something. There's still a penalty. But I do like that concept of, like, having something that's still outcome based. Like, the bad thing happened or the bad thing did not happen. Like, that's, at the end of the day, that's what it's about.
Sounds like you're saying declarative almost. Outcomes based sounds to me like, in cloud native world, like declarative configuration versus what is imperative? Is that
Yeah,
complement?
that's the thought process I hadn't really, a term I hadn't put to it, but that makes sense to me, because it's like, is the pod running or is it not running? That's a declarative. Like, how many do you want? That's a declarative statement. Now, how do you get there? Do you get there? That yeah, that's the how. But what is it? What is the outcome that you want? And I know it's fuzzier. People like the checkboxes because they can say, I did the thing in the checkbox. And outcomes is still, there's still a checkbox there. Did that thing happen or not happen? But it's way more fuzzy. People want to know, this is what it's going to cost me to become secure. They can put monetary cost on each of the controls within the descriptive approach. But when you're saying the intent is we don't want this thing to happen, like that leaves it open, more open-ended than people like. But I think it's probably one of the more important questions people have to ask.
Pigeons are flying, so it's telling us that we're at last thoughts. We touched on a lot of interesting points here. Maybe just before we break, I want to give you a chance to share any last thoughts.
Yeah. So my last thoughts in this is definitely come and join us if you think it's useful, or come and read the information. The information is freely available. We're going to continue to update it over time. Right now, it's a special interest group, but the goal is to turn it into a full-blown OpenSSF project that is maintained like an open source, like any other open source project. It just happens to be that our output is text, but there's but we want to make sure that we have like proper releases over time, that we're tying it to real outcomes. So we're saying like these are actual things that have happened in the industry, and tie it to why this stuff matters. If you find this to be interesting, please come join us. If you're in a related space and you want to collaborate in some way with a different foundation, we're actually looking for SAFE MCP to not just be like a OpenSSF only thing. We're looking towards like how do we expand collaboration with other groups, with other foundations. It just happens that the code will live within an OpenSSF based repository with like code of conduct roles and project health roles. But we want it to be something that is highly collaborative across the whole industry. So thank you
Well,
very much for having me.
and Rohit, last thoughts?
Yeah, what I heard was indeed a changing landscape here of what makes compliance challenging. And to me, that the bottom line is like, yeah, it's this autonomy we talked about, because you're selling it short by saying SAFE MCP's output is just text. The ability of a group of collaborators to put together good warnings and good guidelines on how to put these technologies together is going to become input. Text alone becomes input to the next range of how we teach auditors to audit. And so declarative, saying what the intention is, but then also spelling out how to validate it. So validating that against a model that says, all right, you said you were going to make sure you don't leak a PHI, and here are the mechanisms why, and then automation. And then you can close that loop and make it faster. That's what I also took out of today's talk, but that, the threat has changed. It's not just human to human delegation. As we put AI systems in the loop, we need to be even more clear on the fact that they're not just misbehaving people. And so the governance standards is like your employee handbook. Your employee handbook's written for humans. SAFE MCP can kind of become more of a guidebook and a handbook for how to work with automated agents.
Well, and guys, I apologize for the fumble on the transition a couple of minutes back when I switched to pigeons. But I want to just quickly announce the next episode because the conversation will continue. The title is Securing AI Agent Identity. And the guest is Itzik Alvas, the co-founder and CEO of Entro Security. And so, yeah, it seems like every other episode these days is about agentic AI challenges. So with
They
that,
do create a lot of problems really quickly, don't they?
yeah. So with that, I will say thank you so much. Thank you, Frederick. Thank you, Rohit. Thank you, audience. And we'll see you next time.